Okay. Hey. Alright, so note they are just two like that. So when the spindle fibers attach, in this instance, they wouldn't attach to chromatids. They will attach a full chromosome. So spindle fiber will attach to this chromosome, attach to this chromosome. But note that they will be joined. You get it? And note these things: bivalent, chiasmata, and what? Tetra. I want 3 people to explain these things, or one person who can be able to explain all of them. What do they mean? Bivalent, chiasmata, tetra. You start by mentioning the name of your school. Or you want to or you can mention the name of your school. And after her, I want an last word. Those who that talk a lot.
The bivalent is we are considering the 2 chromatids. So the 2 chromatids of
The 2 chromosomes or the 2 chromatids? You mean this and this,
if
or
you are
this one
considering,
and this
yeah, no, you are considering a single chromosome. Like,
this chromosome?
yeah, the 2 chromatids that form that chromosome make a bivalent.
Yeah, bivalent.
Yeah. And then the centromer, the
Bivalent, chiasmata, tetra.
is according to the tetra.
Okay.
Yes. So but we are still considering the chromosome. You see, from your drawing, we can see that the centromer divides with.
This is the centromere of this one is
Yes.
the centromere.
So the centromer of the one of the chromosomes, yes, it divides the chromatids at a point. So yes, please draw one for me.
This Friday, that's why. Like this.
So considering the 2 chromatids, we can see that the centromer divides these 2 chromatids at a point.
This, like this, or like this. Or you come to that way, that's all.
So these are the 2 chromatids, 1 and 2. And then we can see that the centromer is here. So for the tetrad, we consider it as 1, 2, 3, 4. So that makes a tetrad of the chrome.
For just one chromosome. The other one is not part. So now we just for this one, and this one is not part. Who agrees with it? You agree? Who said the biggest no? The lady in blue. Who said the biggest no? You have a different perspective. Let's listen to you.
The tetrad
Because I disagree with it.
is because of 2 homologous chromosomes. So we can call the 2 homologous chromosomes as 4 chromosomes.
4
Tetra.
chromosomes or tetra. Alright. So for him, he's saying that it is these 2 full chromosomes. You can't get out from the tetra. Right? Alright. So now a tetra will be made up of 4 chromatids. Alright.
And the chiasma is the place where is the point of the intersection where
This place, they will join together.
Yeah.
So this place there, chiasma, right? Plural is what? Chiasma. Alright. Then bivalent.
The bivalent is occurs when homologous chromosome.
When they meet. When they meet again. So we said, wait.
The chiasma is the point.
The chiasma is the point of intersection. And then when they meet, they will form a bivalent. And then what about the tetrad? That whole structure is called a tetrad.
Tetrad, you can call it that two homologous chromosomes or four.
I'm looking for the one laughing, and I'll let you answer a question. It's 2 o'clock. We have to hurry up. Does any one of you have a different answer? Alright, whatever it is, whether it's homologous, anything. You know what he was trying to say, so why are you laughing? If I see you laughing again, I'll ask you. You come to the board and draw. Alright, so I think I agree with you. So note that in meiosis, there is chiasmatic formation, there is bivalent, we have tetrads. Note the meaning of all of those things. So when the separation happens, right, full chromosomes will be separated. So at the end of meiosis 1, we have 2 cells, and the separation will be in such a way that in terms of meiosis, there were individual chromatids that were separated. But here, full chromosomes will separate. Full chromosomes. And so it means that if the cell was a diploid cell, we still have a diploid cell. And so a division has to happen again before you can get the haploid condition. So this one will further divide, just like we have in mitosis, such that you'll be able to divide it. So for example, let's look at the human cell, which has 46 chromosomes. Undergoing, meiosis. What will happen at the end of meiosis 1? You have them. So at the end of meiosis 1, you have how many chromosomes? 23 chromosomes at this side, 23 chromosomes at this one side. And note that each of these 23 chromosomes is made up of 2 chromatids. So another division will happen in each of the 2 cells. And in that case, each chromosome was split into chromatids. So we form 2 cells again from this. One has 23 chromatids, another one has 23 chromatids, 23 chromatids, 23 chromatids. And they all mature to form chromosomes. At the end of the day, a cell that was 46 chromosomes, we're able to have the chromosome number to what? 23. So the major difference to look out for is at anaphase 1. In anaphase 1, note that what is being separated to reach the ends of the cell are full chromosomes and not chromatids. And note that in prophase 1, it is not single chromosomes that are going to align at the metaphase plate, but pairs of chromosomes or homologous chromosomes that are going to align at the metaphase plate. But ultimately, try and know the difference between meiosis and mitosis. So if you get this basic difference, you can be able to simplify the process and get what exactly is happening. But once again, note that I said whatever is happening in meiosis 2 is the same as prophase. It's the same as mitosis. So you only have to know the unique things that are happening in meiosis 1. And then meiosis 2 is just the same as mitosis. Any question? No question. Let's briefly look at the mechanism and rules. I hope nobody has a problem with chi-square. If you have a problem, it means you didn't come for the tutorial on chi-square. And I don't think there's anything we can do about it. But if you came for that tutorial and you still don't understand it, see me. But make sure if you are seeing me, you should be able to prove that you came. How that's fair? Just imagine somebody coming to ask for the same thing we did today when they were sleeping at the hostels. Traits. What else? Homozygous. Heterozygous. Recessive. How do you spell recessive? Is it like this? Dominant. At my age, I don't remember a lot of stuff. Dominant. What else? Co-dominant. Multiple allelism. Incomplete dominance. What else? As many terms as possible want me to explain. What? Test cross, reciprocal cross, back cross. What else? Polyploidy. Hey, explain those things. What else? Come again. True breed. Pure breed. Anything you don't understand. That's all. Mention them, man. Somebody is now looking into the slides. What? Character or traits? Okay. Come again. I'll explain that one out. Yes. That's all. Hey. Genotype. Phenotype. I talked about multiple allelism, right? Then polygenic traits. What else? Definition of epistasis. Okay, if you don't have anything, let me explain the one thing. What? Locus. Please, what's in the time? Pangenesis. What's in the time? 2:08. And the tutorial was supposed to start at 12 o'clock. However, we started at 12:01. So, technically, if you want to go away, you can go. So, I'm giving you 30 seconds. You can leave. Who will be here? But if I start explaining, you can't go. So if you want to go and do something before your lunch, you can go. Alright, it's time out. So what's a gene? There are so many definitions of a gene. Apart from the fact that you've been told that a gene is a hereditary material through which traits are passed on from parent to offspring. the most technical definition of a gene that you can have is that it's the smallest segment of a chromosome where crossing over is impossible. A gene is the smallest segment of a chromosome where crossing over is impossible. Now, most of the times in genetics, we use the term gene and allele interchangeably. Who can tell the difference between a gene and allele? What's the difference? Gene, allele. Are they the same? What's the difference? Anyone who attended Wesley Girls High School? Who? Nobody. Who attended Gay? You. Which school? The disciple. Okay, I'm also a disciple. You want to explain? But before then, I want a gay girl to explain. Nobody attended Wesley Girls. You attended Gay. Hey! And you are lying. What does your motto say? The motto of your school? Live pure, speak true, right wrong. Speak true and you are lying. Okay, anyone else? An allele is the alternative form of what? A gene. But the point is that that's correct. That's very correct. But that's a textbook explanation. And people still don't understand. If you say a gene is an alternative, an allele is an alternative form of a gene. Or you get it, you understand it. You get it. When you write it, you score. But I want you to be able to understand it for everybody to know what's really it's about. Can you go beyond the definition? Like demonstrate.
Please, for instance, from a man, let's say for high,
That is what?
So this gene is for a trait. But it's different. One is after one is.
Alright, I think we have that. So the point is, for every trait, like you said, let's use height. And it's using the letter T to represent height. But we have two variations in height, tallness and shortness. You get it? And for those two variations in height, we have a form of the gene that is responsible for that. So a form of the gene is responsible for tallness, and a form is responsible for what? Shortness. You get it? But both tallness and shortness are height. So those alternative forms of the gene that controls those two variations, each one of them is an allele. So what is responsible for tallness is an allele, and then the one that is responsible for shortness is also what? An allele. But the two of them collectively will comprise what the gene is. You get it? Alright. So that's what we always mean by saying a gene is an alternative form, an allele is an alternative form of a gene. Alright. So then what's a trait? And the difference between a trait and a character. Who can explain? If you attended Massey High School, raise your hand. Nobody. Nobody attended high school. So those of you sitting on the front row, which schools do you attend? The man behind the camera, which school?
Massey High.
Massey High. Kindly explain the difference between a trait and
A trait and a what? A trait and a what?
a trait and a character. Or if you can't explain the difference, just tell us what a trait is.
Okay, so I can say that a character can be like height. That's the character.
A
And
character can be
trait,
what?
height.
Height.
Yes, and a trait can be maybe shortness and tallness.
Alright. You agree with him? Yes. You agree with him? Alright, he's saying that for character, you can say the character is height and the trait is tallness and what? Shortness. Is that not what you're saying? That's what you said. Alright. So a character is any what? What the word to use? Trait or character is any I want to use characteristic, but I can't be explaining the word character with characteristic. Any whatever word you want to put there under discussion. You get it? So in a particular genetic experiments that you are making, whatever feature of the organism that you are investigating, whatever feature of the organism that's under discussion, that is the character. And the different variations, alternative forms of it will be the traits. You get it? Alright. So for alleles, we have alleles that are responsible for controlling dominant traits and recessive traits. But let me talk about recessiveness and dominance. You know the tale about the cat and the mouse? You don't know about it? Why did you attend it? That trait about cat and mouse. When the cat is around, the mice cannot come out. So for example, this room, assuming there are mice in the cupboards, the lockers around, when there's a cat around, or your cat around, those mice cannot get out and play. But when there is no cat, you come and see a lot of mice roaming about and fooling around. You get it? So let's assume the cat is the dominant trait and the mouse is the recessive trait. You get it? So whenever the gene that controls the dominant trait is available, the recessive trait or the recessive condition cannot be expressed in the phenotype. You get it? So whenever the dominant gene is available, the recessive gene cannot express in the phenotype. So the dominant trait is like the cat, the recessive trait is the what? The mouse. So the only time you see mice around is when there is no cat. That means the only time that the recessive trait will be expressed is when there is no dominant allele. That means that both alleles present are what? Recessive. And normally you use capital letters to represent dominant alleles and then small letters to represent recessive alleles. So let's take height and use the letter H for height. Big H will be the dominant allele and small h will be what? Recessive allele. Because we can have various combinations of these alleles because of the law of independent assortment. We can have an individual who has the genotype big H, big H. Another person can have big H, small h, and then somebody can have small h, small h. Right? These are the various combinations you can have with no respect to other. Let's look at these two instances. In both instances, we have the same type of allele showing up. In such a situation, we say it is a homozygous situation. So this is a homozygous, and this is also homozygous. The homozygous situation is when you have the same type of value expressing itself twice within that particular gene. But the point is, if you could just say homozygous, then what would be the difference between these two? So you should be able to create the difference by specifying which type of variation of the gene is repeating itself. Because here is a dominant type, then this one is homozygous dominant, and this is homozygous recessive. How about this? It's going to be heterozygous. So heterozygous condition is when you have the different combinations occurring out. How to get it? So in terms of genotype, these are the possible genotypes you can have for every trait. Both alleles being dominant, or both alleles being recessive, or one dominant, one recessive. In this case, homozygous dominant, homozygous recessive, heterozygous. These are genotypes. It means that genotype is the genetic constitution of the organism. What is in there, what particular gene is present within that organism. Phenotype will be the expressivity. And note these terms: penetrance and expressivity. The fact that you have a gene doesn't mean you show the trait that is controlled by that gene. That is simply because of the issue of dominance, codominance, metastasis, and all those things. Because of that, just having a gene is not a guarantee that you will express the traits that's controlled by that gene. So, in this instance, this homozygous individual, assuming tallness is a dominant trait, this individual is going to be tall, right? And how about this guy? Short. This guy is going to be what? Tall. This guy is tall, but he has a short gene, a gene responsible for shortness. It means that there is penetrance of the allele for shortness, but it is not expressed. So in this case, in terms of shortness, there is penetrance of the allele, but there is no expressivity. It means that the allele is present in the genotype, but it is not expressing in the phenotype. You get it? Alright. Now I've talked about this, that. Remember Mendel's law. But I hope you've learned a little about Mendel, the history of Mendel, who he was, how he lived, the kind of things, the food he liked best. Oh. But how is it bad to know the food he likes best? But you didn't learn that one. Alright. But I recommend that in your free time, you watch a documentary about Johann Gregor Mendel, the man who is behind all of these types of genetics that you know. And you also watch a video documentary about this guy, Darwin. And the point is, it's always said that in life, for every breakthrough, there's 99% perspiration and then 1% inspiration. So it's not about your hard work alone. It's about some divine inspiration that should be able to let you meet the right people, be at the right place, and do the right thing at the right time. That's all that sometimes makes the difference. So you can sweat perspiration for 99%, but you need 1% inspiration. That 1% inspiration Mendel didn't have. And you've read about him. He did, you know when he was born. You know his mother's name, his father's name, his grandfather's name. You don't know about that. But you know where he was born. You know where he comes from. Well, he was an Austrian monk. And he was a reverend father. That's why he's a cripple. And at a church premise, that's where he made his backyard garden. And he planted certain crops and he studied them over time, several generations. What's the name of the plant? Pisum sativum, garden pea. And why did he plant that specific plant? There are several reasons why he planted that. One, because it was an ephemeral. What are ephemerals? What is an ephemeral? Anybody who attended the Pantlim school? Somebody said I should mention names of schools again. Yeah. If you attended the Pantlim school, please raise up your hand. James Shekan. Nobody. Okay, anybody?
Minerals and annual plants, or the complete and cycle a year.
So in most textbooks, you hear that Mendel planted Pisum sativum because it was an annual plant. But guys, it wasn't just an annual plant, it was an ephemeral. Ephemerals are not just they are not your average annual plant. Those guys can complete multiple life cycles within a single season. By definition, annuals complete a life cycle in just one season. But for these guys, multiple life cycles in just one season. It means in just one planting season, you can harvest them about 3 times. So that was it. It was an ephemeral. It has to complete the life cycle. I think about 6 weeks or something. So it means that could enable him to study several generations over time. You get it? Just imagine Mendel carried out the experiment on coconut tree. Right now, he would have still been doing the experiments. And we'll be done with just 4 generations. It's very difficult because it's really had a short life cycle. He plants, then he harvests the seeds, plants the seed, study the offsprings, then they produce seeds, he plants again, and he's able to study them effectively. Another reason was that it could be cross-pollinated, right? And self-pollination and cross-pollination were both possible. Another reason again is that it had very contrasting characters. All of the traits that were available were very contrasting. There were no intermediate. For example, there were true breeding tall plants and then true breeding short plants. So you have the true breeding tall plants and you have a dwarf plant. You have those that produce white flowers and one that produce which type of flowers? Purple flowers. You have that produce round seed, wrinkle seed. There are always 2 contrasting variations. So you could be able to study the various variations as soon as possible. For this and so many reasons, Mendel chose that particular plant. But one thing that is very inspirational about this is that Mendel studied 7 traits about that plant. But coincidentally, by that time, Mendel didn't even know about genes. He didn't know about genes. Today, you guys know about genes, you know about DNA, you're able to understand a lot of things that Mendel never knew. He had no idea what a gene was. In fact, what he thought was that something was responsible for passing on the traits from the parents to offspring, and he called them factors. He said some factors were responsible. He didn't know what those things were. And one thing that was really inspirational is that he studied 7 traits about that plant, and coincidentally, that plant had 7 chromosomes. By that time, there was no knowledge about chromosomes. Coincidentally, he said these 7 traits, they all had 7 chromosomes. And then, none of those 7 chromosomes, none of the genes on those 7 chromosomes were linked. And the point is, if any of them was linked, it would have changed his whole entire result. But coincidentally, none of them was linked. So Mendel finished the experiment in how many years? 6 years, right? Used about 6 years for the experiment. And he compiled his results and published it in the journal, the Scientific Society Journal of Brunn in Austria. And was published all right. But Mendel's work went unnoticed and unrecognized by the scientific community for about 30 years before it was rediscovered by 3 scientists. You know their names? Those guys who rediscovered Mendel's work. You don't know about that. So when Mendel published the work, no attention was given to it. Everybody ignored it. Nobody spoke about it. For about 15 years, Mendel died. And when he died, about more than 14 years later, that 3 scientists, through reading, went to discover that particular work. That this was what Mendel had done for about 30 years ago. They rediscovered the work, republished it, and then attention was drawn to it. Most of the time, the questions are why was Mendel's work ignored for a long time? One, because Mendel was a mathematician and not a biologist, was not a scientist. And the point is, you cannot be a mathematician and be coming to school biology professors on how inheritance occurs. Who does that? So nobody took him seriously. And it's nobody's fault because it's something that is happening. Credibility is important. And who is talking is as much important as what he's saying. So assuming one of your friends just stands up and says the class is cancelled, would you just walk out and go to your hostel? even if it's true, assuming your mate was just walking around and then you saw the tear and the tear told you to come in and tell the class that the class is cancelled. They comes to tell you that's authentic information. But everybody will be doubting. You might be wanting to verify from the class rep or whoever. What if the class rep puts on the page that class is cancelled? Everybody will be happy. Start posting your stickers and all of those things. So, credibility of the message is tied to the person giving the message. You cannot be a mathematician and be schooling biology professors about inheritance. You get it? So because of that, nobody really took him seriously. But secondly, around that same period that Mendel published the work, that was when Darwin had discovered the theory of natural selection. And it was a very controversial theory that everybody was talking about. So Mendel's work was lost in the shadow. It was just shadowed by Darwin's work. But exactly what Darwin was talking about was exactly what Mendel was talking about. And if Mendel had met Darwin, the story would have been different. Because the right keys that Darwin needed was what Mendel had. And those guys never met. So they both died. Who is saying how? So it was really a problem. So he was a mathematician, and then Darwin's work was also the subject of controversy. But then again, he also didn't publish the work in a very appropriate manner. The thing is, if you want to do a very great scientific work with such impact, you should publish it in an international journal. That journal he published it in was just a local society for scientists. And your principles of schematics, have you done that? In publishing scientific names and all of those things. You should publish it in a most appropriate manner, in a scientifically recognized journal. So assuming I have a research right now, and I want to publish my findings, I just don't have to go and see HypeGH or the Hub to just publish it for me. And I say that the Hub has published it, so scientists should take me seriously. Who cares about Campus 360? Nobody. So for example, if I'm publishing it in a Sub-Saharan African magazine for scientists, and those magazines, if you are and scientific journals, you are publishing your work, you pay a lot of money. So just imagine you are paying about, let's say, $50 to get just one work published. And most of that's even for the lowest journals. But for very high-reaching international journals, sometimes you need to pay about $5,000 to get your work published, such that scientists across the world can be able to read what you have found out, to get recognition, get peer reviewing, and you get the attention. Everybody begins to look into your work and then move on. But if you don't do that and you just publish it anywhere, your work will be in the shelf for long. Nobody recognizes it. So that was another mistake that Mendel did, for which his work went unnoticed for that long time. Alright. So the three scientists who discovered the work, one of them was Hugo de Vries. He was a Dutch scientist. Hugo de Vries, and then the other one was von Schirmacher. Schirmacher, I've forgotten the spelling, right? Something like this. No, I don't remember the spelling, but I get a sound. Go and search for it. Schirmacher, von Schirmacher, Hugo de Vries, von Schirmacher, and then who was the last person?
Correct.
I forgot to go and search. 3 years ago. Nice.
Correct.
Alright. So Mendel brought 4 laws of inheritance. Law of dominance, law of independent assortment, law of segregation, and the law of unit character. Have you heard of the law of unit character before? Exactly, because it didn't make sense. So that law was dropped instantly. But so in recent textbooks, nobody tells you about that because Mendel has died for a long time, and he's the father of genetics, and so we want to tell the most interesting stories about him. And it's amazing how biology teachers are always praising Mendel and saying all the great things about him, and always making people like Lamarck look very ridiculous. You know what that man said?
Yeah.
For example, if you're a macho man and you have a very big bicep and tricep muscles, you translate it to your children. If you're a driver and then you can drive very well, your children will get it. That makes sense. So giraffe are able to stretch their necks for a long time, and so they pass it on. Said that you can transfer acquired characteristics. That thing doesn't make sense. But that's exactly the single story that people will see about Lamarck and rubbish everything that he did. But in fact, he served as one of the foundations for a lot of work, even in genetics. Let's give him the respect that he deserves. So Mendel, he brought 4 laws. The law of unit character says that every single trait is controlled by one gene. Every single character is controlled by one gene. And that's a lie. So that law was dropped instantly. So it remains with 3 laws. And that's what's the subject of the discussions that we have most of the time. Law of segregation, that shows that during fertilization, the the alleles of a gene will separate, and each allele will go enter one single gamete. One gamete will contain one separate allele. But there will be separation of homologous chromosomes during fertilization. That's about separation. Then the law of independent assortment. That shows that when you have, for example, when you are doing process in genetics, for example, you have a parent who is tall, big T, small t, with another parent who is this. You realize that this guy can combine with any one of these. It can combine with this and combine with this. So the probability of combining with this is independent of the probability of combining with this one. So the assortment of that particular combination is independent. That's basically what the law of independent assortment is about. That during fertilization, any one allele of a pair of alleles can combine with any of the other alleles within another pair of alleles. Then what law is left?
Dominance.
Dominance, right? I've explained dominance and recessiveness. The law of dominance is not a universal law. It has several exceptions. And what are the exceptions? The exceptions are 1, codominance, and then incomplete dominance, and then even epistasis. They are all exceptions to the law of dominance. Why? What happens in incomplete dominance? So let's assume in Mendel's experiment, we have a plant that produces white flowers and one that produces red flowers, right? In the issue of dominance and recessiveness, with the law of dominance, it says that if white is dominant over red, then if a red flower is mated, a plant that produces red flower is mated with one that produces red flower, white and red are mated, and assuming white is dominant, then the offspring should be what? Assuming white is dominant, and then you mate white and red, what would your offspring be?
White.
It will be all white, because white is dominant over red. If red is dominant, then they all be red. That's the law of dominance and recessiveness. However, we have certain instances where you realize that you have pure breeds. But for example, you mix red and white and then you have pink. You produce pink flowers. Why? What type of condition is that? That's incomplete dominance. In incomplete dominance, we have a blend of both extreme traits. We have a blend of the two traits that are coming together. So red and white blending will give you what? Pink. Is that okay? But what about codominance? In codominance, you realize that pink is not the extreme form of red, and it's neither white as well. So none of them is expressed fully. In incomplete dominance, in codominance, all of them will be expressed fully. So, for example, you have a white flower, the background is white, but then you have red patches. So it means that wherever you have white, it's complete white, pure white. And wherever you have a red patch, it's pure red. Do you get it? So the red, the color intensity has not been reduced. It's full red. Then the white is full white. All of them has been expressed at the same time. That's codominance. Note the difference between codominance and incomplete dominance. In incomplete dominance, there's a blend. The two will merge at a middle ground. So if you have pink, pink is neither white nor red. But if you have codominance, all of them will appear at the same time. So you have, for example, if you have cattle, you have a cattle that has white fur with dark patches. That's codominance. But if you have incomplete dominance, you have a certain cattle that has some brown fur. That's a mixture of white and black. Is that okay? Multiple allelism. But so the law of dominance is not a universal law. And then one of the laws is also not universal. There is only one of Mendel's law that is universal. That's the law of independent assortment. That is the only law that doesn't have an exception of all of the Mendel's law. The law of segregation also has exceptions. And what's the exception? Linked genes. In linked genes, there are certain genes that are always inherited together.